coming to our special briefing for Hurricane Matthew. I don't know about the rest of you, but this is pretty much the only thing I can think about for like the past 24 hours. So this is Matthew currently. As of last forecast advisory is about 120 knots, and I actually don't remember what the 10 a.m. advisory was. Did it increase at all, or is it still 120?
It went up to category 4.
Yeah, 120 is category 4. Okay.
Yeah.
So very impressive storm. Also, just looking at it quickly in the infrared, we'll just bring up this loop. You can see a very broad area of very cold cloud tops. Unfortunately, this isn't listed here, but I'm guessing they're somewhere between, -70, minus 70 Celsius to about minus 90 Celsius. So very cold, very large, dense area of cold cloud tops. Actually, that's what that was, so never mind. We'll skip that tab. So going into the current analysis of Matthew, fortunately, thanks to everyone upstairs, our CIMSS TC page is still working. Would you say like 13 or 17 million hits yesterday?
17 million.
17 million hits on the CIMSS TC page, and it's still up and running right now. So thank you. Yeah. So thank you, TC upstairs, not tropical cyclone, technical computing.
So for people who are here in 1995, when they first started a website here, hurricanes would just, the entire center's website would just go to
Not only the center, the university would go down, the whole university.
Wow.
There's been improvements in the last 22 years.
Yes, and fortunately, we had 10 years to improve it since our last major landfall, which is what this is looking like it's going to be. Yeah. So anyway, here is the infrared of Matthew. Matthew has a very well-established outflow channel to the north, so it's able to exhaust all of that upward motion that's coming up through Matthew. If we look at the shear over Matthew, I'll get rid of the upper wind just because that's kind of confusing. So it still is in an area of favorable shear, maybe starting to get to an area of slightly unfavorable shear. There's a chance part of this is also just related to Matthew's outflow. So part of it's probably the outflow. It may also just be slightly unfavorable shear. What am I looking for? I can never find these when I want to. Of course. Oh, there we go. SSTs are very favorable for Matthew, as is ocean heat content. Matthew's pretty much in an area that hasn't gotten disturbed by tropical cyclones in quite some time. So therefore, there's a lot of. Are very
Wow.
Alrighty.
You know what the time lag is.
It's working.
Okay, for those of you who don't know what just happened, I just heard a replay of myself, and that was kind of weird. And yes. And then just finally looking at total perceptible water, still a very moist general, or the environment in general is very moist. Also wanted to take a look at the ADT. So the ADT definitely showed some intensifying. According to Chris, some of the ADT was related to the structure of Matthew last night, which we'll get into later. Matthew, we had that beautiful eye yesterday, and we have it again now. On the satellite image, we actually did lose it for a little bit, so the ADT may have gotten increased a little bit. However, it's definitely showing that Matthew is intensifying, even if we have this little bit of a decrease in the ADT from what it was. It's definitely a very clear indicator that Matthew is intensifying and has been intensifying since our briefing yesterday. Also just wanted to show you the ASCAT. This pass is from about 2:45 UTC this morning. All of these black flakes here are rain flags, so I'm not sure I would quite believe them. However, we do have a couple of wind barbs hiding in here. Here's a couple of flags indicating 50 knots. This is 10 minute sustained winds, so the rule of thumb is to usually add 10% in order to get what the 1 minute sustained for the National Hurricane Center would be. It's also interesting that this is at 2:45 UTC. Nassau, Bahamas is located on the end of this island. They started experiencing the hurricane and got hit probably around 8 or 9 local time, which is around 12 or 13 UTC. So we at least at this point, we definitely had a very compact hurricane. The strongest winds were very compact, I should say. The broad winds surrounding Matthew were quite a bit extended. So just to show you some video from Nassau. This is from Kevin Bent. I don't know who this person is. I just found it on the Weather Channel, went, that looks really cool, so I'm going to show everyone. He says he was located 1 mile northwest of the Nassau airport and shot this video. So palm trees you can see are definitely swaying. I've been told palm trees are a very hardy tree, but definitely to a point, yes. But definitely swaying. It's definitely windy. You can see some smaller debris flying through the air. And this was about during the eye wall, and I don't think Nassau quite got the worst part of the eye wall. I believe they were just outside of the main eye wall.
Apparently the coconut varieties are one of the most deadliest projectiles in this kind of a situation. They just,
Yeah, things that I would not want to get hit with would be a coconut.
100 miles an hour.
Yeah. Yeah, how do you report that? All right, so going back a bit, let's just stop this and start over. This is what we were showing you yesterday when we had a briefing. This is Matthew. Yesterday we were talking about how pretty the storm was. We had a very nice eye. A lot of that started degrading overnight. If I just step through this, and here's about our weather briefing time yesterday. We were talking about such a beautiful storm, nice cleared eye. As we started going last night, we lost the eye. And the eye definitely started filling in. It definitely lost its appeal when it came to look. But as you can see, this is a visible imagery, so here are some overshooting tops. It definitely was a very convective storm. And as we continue through this morning, again, this is around 7 or 8 o'clock our time this morning. We still didn't have an eye, but as we keep going forward, Matthew's now developed. It's a very nice eye again.
Is that that kind of explosion of the cirrus outflow just before you sort of lost the eye? Is that just because of sunset, or was that actually?
There's a couple theories.
You back up a little bit. There's a really, you start really seeing the outflow.
Yeah. One of the theories is that there was a little bit of moisture instability, and so therefore there was like asymmetric convection, and you can kind of see that in this next loop. These are the cloud top heights. The cloud top heights were developed by Andy Heidinger and his group. So this is just an animation of the cloud top heights over Matthew. If I just jump ahead and then start over. So this was yesterday around briefing time. You can definitely tell that Matthew, you can see the eye even in the IR. The cloud top heights aren't very high. And as we jump forward, this is in 30-minute increments. You can start seeing these increasing in heights. And this is a convective burst that was associated, that Matthew had last night. And you can kind of see it start wrapping around, almost look like it developed a new eye. And then now we have very tall clouds surrounding all of Matthew's eye as of last night, and then as the eye keeps appearing this morning.
Yeah, Brad, there's also pretty well documented now by Jason Dunyan. There's a diurnal impact, a diurnal cycle, and that really fits nicely with this presentation.
Yeah.
Overnight is when you'd expect it to sort of expand.
Mm-hmm. But when it expands, does it mean we would lose the eye, or would that just be almost the?
No, not necessarily.
Yeah.
Could it just be that there was more serious obscured?
Right.
Yeah. I think this loss of eye was probably due more to a lot of this cirrus coming from the convection that fired to the northwest of the eye wall, of the eye in the northwest eye wall.
Because it does try to fight back. The eye does try to appear again.
Yeah. And it was these small eyes that we were looking at is what we think the ADT may have also been keying on. One thing you also see coming through as we go through this animation, this is made for the Shout Field experiment. So we've plotted the cloud heights, lightning for the global hawk. We also plot global hawk track. So if you saw that thing kind of flying off towards the northwest, there it went. As you can probably guess, Matthew's been a very sampled storm. I stole this from the CIMSS Facebook page last night. The global hawk is circled here. That's a blue track. The G4 is this red track. The P3, which is one of the hurricane hunters and goes in storm, is this yellow track. What we don't even have plotted here are the Air Force. And at my last count, you could track up to 4 Air Force planes on recon right now. Some of them are just transiting back to Biloxi. Some of them actually didn't move. But there's a lot of aircraft investigating the storm right now. So just doing a quick refresh on this and see if anything new has come in. This is Air Force flight from this morning. I do have the recon obs, and you can also see this nice drop in pressure as it kept going through the storm, and the storm kept going off to the northwest. One of the drop zones from the plane. This is in the southeast eye wall. The mean winds in the low is 150 meters. It has at 139 knots. And you can definitely see these very large, or these couple of flags indicating the wind speed. And that is one thing Matthew has done. So this is in the past 24 hours of central pressure for Matthew, starting from yesterday morning to 8 a.m. this morning, Eastern time, so 7 a.m. our time. It was holding very steady, 960s, 964, 963, and then just started dropping. So right now we have about a 940 tropical cyclone. I do not believe the winds have quite caught up to the pressure, which is probably a good thing. This could be something that was also related to when we saw that convective burst last night. Last time I remember checking right before going to sleep, and it was something like Matthew was dropping a millibar every 20 minutes.
So what was Andrew's first back in 1992? Was that the lowest pressure was like 920 with that one, or was
Yeah, I think-
930s?
I think it was lower than that. Yeah.
And what was Matthew's pressure before it hit Haiti? Was it around 940? Was it in the, is this the lowest it's been?
No, it was in the 930s for a while
Yeah.
before Haiti.
Five.
This is Cat 4 now, and it was Cat 5 actually in the Caribbean.
So then finally, I just wanted to end with Mimic, just to see what's going on with the eye wall. I believe Chris is going to talk a little bit more about, as you can see in some of these, especially in the radar imagery, we're probably starting to get concentric eye walls and even an eye wall replacement cycle. So with that.
Right. So I will close this. So we'll look at the forecast now for both the track and the intensity. And already we've been humbled a little bit from yesterday's forecast in various ways, mostly the intensity forecast. I'll first bring up the Hurricane Center forecast for the track over the next few days. And kind of similar to previous tracks, coming close to the landfall location here at Cape Canaveral where Gozar is stored, hopefully safely. And
So-
then now it's picking up this looping track that some of the models were showing yesterday, the GFS in particular.
So my brother-in-law's beach house, St. Augustine, is probably not going to be there.
Depends on how well it's built.
It's right on the beach, right on top of the sand dune.
Hmm.
The sand dune's already been eroded.
Hopefully without him in it, right?
Right, yeah.
Okay, that's good.
First there's the surge, and then
Yes.
Yeah, I'd be worried about the surge.
So is there an analog for a hurricane tracking right along the coast to see how that affects the wind speed and the strength of the storm?
There's,
Just
Not
kind
quite
of
like
straddling
that. I don't
like
think
that?
quite
No,
like
you would
this.
know.
You would
better.
know.
no, I'm just saying this is a rare event. I would say this is like the worst case scenario.
Yeah,
There's been a couple that have tried to do this, but have gotten either offshore by a little bit or come on shore. Something right on the coast like this, I don't recall having it.
Always find the best
But certainly you're going to get an erosion of the winds on the left side of the storm from the frictional effects from the land. But, you know, if this thing goes in 10 kilometers inland, it's a good thing in that it'll decrease the intensity of the storm, but it's a bad thing because you'll get the right-hand side of the eye wall actually over the coast.
Yeah.
So it's sort of a tough one.
Yeah, so storm surge for a longer duration and
Yeah.
heavy rainfall for a long duration. Again, some of the positive news, and it's more certain at this point, that it won't impact too far north of the Carolinas, but South Carolina is still in a very dangerous area. And the other thing of note is that the Hurricane Center is predicting a major hurricane all the way up to northern Florida. So that's a long time period of destructive hurricane force winds. So yesterday we were looking at some GFS solutions that were actually making landfall in Florida. And again, it's really like the track error is not too much. the track forecast has been pretty good, but it's just like a 20 or 25 mile tweak in the track makes a world of difference in the impacts for the landfall and also the hurricane. If the hurricane goes on land, it's more destructive for that one spot, but it also weakens the hurricane more rapidly, preventing further destruction downstream. On the other hand, if it stays off the shore, like Chris was saying, it could cause a lot of havoc up the coast. So here's the GFS ensemble from 6. Yeah, I was. Almost all the solutions now are showing this looping pattern with a second impact on Florida. A few still showing it going out to sea. We'll talk about the future intensity. The good news is that the storm will be hitting a lot of adversity over the next few days. So its second landfall in Florida might not be as threatening. But of course, the rainfall won't help disaster cleanup efforts.
Forecast landfall on the Yucatan Peninsula.
Right, and this is true in the
10 days.
12Z too, as a weak low with heavy or decent widespread rain. So looking at the tendency of the forecast, you can see again the forecast hasn't changed much, but just small tweaks makes a world of difference in the impacts. The 12Z is not on here. The 12Z actually comes further inland again, like yesterday's 12Z. And then here's the ECMWF from 0Z last night. The new ones should be just coming in now. It's kind of similar to GFS. It does show a few solutions curving back to Florida, but a lot more of them going out to sea. And maybe disturbingly, a few that go further up the coast. So, but the most likely scenario is this area up here is pretty safe. But again, you can see a lot of solutions either making landfall or just staying off the coast. So this is still an unanswered question, what will occur. Here's the tendency of the ECMWF. Actually, the more recent ones showing more of a landfall impact than previous forecast. So the overall synoptic environment, this is the mid-level height field showing that the steering flow around the subtropical high is pushing the storm off towards the northwest. And you can see Nicole out here in the middle of this high, almost close enough for binary vortex interactions. So it's a very exciting event for atmospheric dynamicists. And then as this trough moves to the east, it will start to curve the storm off towards the northeast, as we saw in the track forecast. We could take a look at some of the track forecasts here in the, let's see, I guess I'll just bring up this plot. So this is the GFS showing the storm making landfall now in the latest run. Pretty close to Cape Canaveral, and then hugging the coast, either on or offshore. I'm not quite sure from this perspective. And you can see the entire time a lot of heavy rain to the north of it. So flooding will be a very significant concern.
Notice right there, Chris, in that period off the coast as the upper level support really gets blown off in the shear. So what's left is really a low level vortex. So even though you see this big loop coming back, it's probably going to be just a real shallow leftover type of inertia system.
Right. And then it comes back to Florida, but we won't focus too much on the long-term forecast. Maybe at the end we'll take a closer look.
Nicole just hang out there then that whole time? Nicole kind of just goes in circles?
Well, it's been doing that. The more recent GFS extended outlook, it starts to get interesting with Nicole now. It starts to move it around, do some weird loop patterns. It's really anyone's guess where it could go, but it could get interesting.
Could you do that loop again?
Sure.
So do you think there's vortex interaction there? Because
Yeah,
before
you can see it
Nicole was
rotating around each
getting
other.
absorbed in, and now they're kind of dancing.
And that's why it's real important that Nicole is getting stronger now.
Right.
It's becoming its own
Right.
built vortex, and it may become the dominant vortex later in the dance there.
In fact, if I go over to the Spaghetti-O plots, this is the GAF ensemble. This shows the center of each low in a bunch of different runs. And you can start to see that there are scenarios where the storms interact really closely and others where they don't. But you can also see the uncertainty of what's going to happen. But definitely a complex and interesting scenario. UCMWF is pretty similar, so I won't show that. All right, so let's go to intensity. Lots of interesting things to talk about here. Back to the PowerPoint. First of all, this is somewhat outdated. This is from 12Z this morning. Obviously, the intensity now is up to 120, so the NHC forecast was pretty good. And the statistical guidance kind of going pretty similar to NHC. So in the next 24 hours, it shows it peaking out at about 120 knots, what we're currently at, and then weakening mostly because of landfall. But still being a hurricane all the way out to 72 hours in a lot of these solutions. This is the earlier numerical guidance. You can see already that a lot of the models underestimated the storm. The COAMPS has always been on the upper end, and it did a really good job in this case. So it finally didn't get a false alarm. Followed right along to what actually happened. So
and that's a coupled model, so it has an ocean underneath it.
Yeah,
It's real
yeah.
important in this case.
I think HWRF does too, but it just was under predicting it. Now, of course, the new HWRF has come in, and that output's not available yet. The Hurricane Center has been a little aggressive. When we were here yesterday, we were at this point, and this red is the actual intensity, and the Hurricane Center was predicting intensification. Instead, we saw weakening. Sorry, it was probably in this time period. We saw some weakening, or when it attained 105 knots. So it kind of never lived up to its billing for the following day. And then, of course, this morning it took off and essentially was undergoing a rapid intensification rate up to the current time. So it just took a little longer to intensify. And some of that could be due to the vertical wind shear, which appeared to be out of the north, being a little stronger than predicted. Honestly, don't know. Or if it's tied to other land-ocean interactions. And then at this point, the Hurricane Center continues to show strengthening up to 125 knots, and then weakening. All right. So just looking at the ships, this is the statistical model showing maybe we should use D-ships, the land version.
Chris, can you make that full screen? It's kind of hard to see.
Sure.
At least I.
If I know how to
No,
use
if you go-
PowerPoint.
If you go to slideshow, there you go.
All right. So ships also, again, was pretty consistent with NHC, shows the intensification up to Cat 4, and then weakening out to beyond, especially decay ships. Well, it's actually the same. It's a little weird. You can also look at some of the environmental parameters. The vertical wind shear currently is probably in this ballpark. That seems pretty reasonable, 4 to 7 knots, pretty light shear. Out of the north, now changing more to the west. And then it really ramps up 36 hours out, so that will become very detrimental to the storm. The potential intensity, and this is a key point, the potential intensity shows a Cat 5. So in a perfect environment, the storm could reach a Cat 5. And that's because you have very warm SSTs, as Sarah showed. You have a really good ocean heat content. It's very moist. Basically, the storm's potential is to get even stronger. I won't look at that. And Sarah already showed that we're in a favorable environment. Some of the other parameters from the statistical output, looking at the RI probabilities. Yesterday, they were close to 0, max maybe 11%. Now, all of the different statistical models are showing a decent elevated probability of RI in the next 24 hours. Of course, this is kind of verified because a lot of that has already taken place. But here's the hang up. Yesterday, we were seeing high probabilities of an eyewall replacement cycle. And if you look at the radar data, we're seeing a mature concentric eyewall configuration. So a lot of the stuff we looked at before with storm's potential to get to Cat 5 doesn't account for this. And now that we do have an ERC, Jim Cosson has developed this product to predict what will happen to the intensity when an eye wall cycle is present. So before we saw the storm continue to ramp up to 122 knots, but with an eye wall cycle, based on climatology, we expect it to actually weaken over the next 24 hours down to perhaps below 100 knot storm prior to landfall. So statistically, this eye wall replacement cycle implies that the storm's intensification might arrest and might actually might weaken. Of course, that's not a guarantee, but the good news is that a Category 5 type storm is probably unlikely because of this eye wall replacement cycle. We saw that. And okay, so we'll now take a look at some more of the numerical guidance. So here's the GFS again. It's predicted to make landfall around Canaveral. And then actually this 12Z GFS is overland completely. So that'll weaken very quickly if that's true.
When would that happen?
Over the next 2 days. So in about a day, it'll be making landfall. And then over the following day, it'll be weakening.
Chris, with the eye wall replacement cycle from this stage of the dual eye walls, is there a lot of variability in the time it takes to complete?
Yeah, there's a considerable amount of variability.
Yeah.
In some cases, this could happen very quickly. My feeling on this is it's a very large moat, so it's a very large outer eye wall. It would be very surprising if this thing completed. Now, if it did complete, that would be really bad. That would be like kind of Hurricane Andrew 92. Prior to landfall, it had an eye wall replacement cycle, and it completed, and then it was a Category 5. And the environment is very favorable in the next 24 hours for further intensification. And right now, we see probably are seeing a competition. The inner core has become a Cat 4 during this ERC, so it continues to benefit from the favorable environment. But it's really just a matter of time now. Its days are numbered with this outer eye wall starting to.
There's kind of a question, Chris. Most of those ERC models were developed on non-landfall cases, right?
Yes.
So, you know, is the land going to interact with that outer eye wall and begin to erode the outer eye wall first? And
Yeah.
if that's the case, it could actually benefit the inner eye wall.
That's right. So this is
it gets complicated.
There's probably at least 1 or 2 peer-reviewed research papers out of this case.
Just from you, right?
Yeah, we should get on this.
Is there a typical time frame for the replacement cycle?
I don't remember the exact number. I want to say in the ballpark of a day, but depends when you define the beginning of it too. Like, in my opinion, this process started long ago, probably well overnight, if not earlier, as the wind field expanded. But based on radar, it was more recent that it became obvious.
So at what point should we start seeing the inner eye wall starting to fall apart?
Probably soon, but
Okay.
this is a huge moat, so this could go on for a while as a very healthy inner eye wall. That's the other factor. This is almost like a Western Pacific eye wall replacement cycle. It's just classic. And you can see right now the inner eye wall looks very well intact. You can see vortex Rossby waves or some kind of wave activity, which in filamentation going on inside the moat. It's just really cool.
That was an excellently vague answer.
That
That was a very vague and excellent answer, by the way.
So that outer eye wall is
That potential is about
a significantly larger one. Why wouldn't landfall really disrupt
It probably will.
Yeah.
We'll take a look at that. The HWRF actually captured that with the initialization. So that's just one possibility. We'll see what happens. But let's go back to the overall forecast. Right now, it's obviously in a favorable shear environment. But as we go further in time, this is the forecast shear, with the red being really destructive shear for the storm, destructive for the storm. As it makes landfall, it starts to interact with the vertical wind shear associated with this shortwave trough that's moving eastward towards the Atlantic. And that alone should also weaken it, besides the landfall. And it'll be in this vertical wind shear for quite some time as it emerges out into the Atlantic. So, you know, as it goes back out over the ocean, it will probably be in a very compromised state. But it will be interesting to see if it somehow makes it through this pretty healthy. Things could get interesting later on. But at the moment, it seems more likely than not that it will really take a beating from both landfall and the wind shear. And of course, Nicole's out here. That will be interesting as well. Dry air is also an issue. Of course, when any storm makes landfall, it starts to wrap in dry air, especially with the trough interaction. Rainfall is a major threat for anyone in the path. Even if it weakens very rapidly, this thing will pack a lot of destructive rainfall with up to well over a foot to maybe 2 feet in some areas. Yeah, so even if the storm is pretty weak by this point, you see the rainfall potential is pretty high, even North Carolina. And of course, Virginia might get some heavy rainfall as well. This is ECMWF. I haven't looked at this yet. This is hot off the press. It seems to show Cape Canaveral again.
But they don't, why don't they show anywhere near as much erosion in the wind field?
It's a global model.
Oh yeah, sorry, this is 850.
Oh,
Good catch.
There you go.
Yeah, really close to the coastline, but perhaps some landfall right by Cape Canaveral. Does anyone know how secure GOES is, by the way?
It's in some building.
You don't want to know.
So Greg
Trust our
Mant,
government.
yeah.
They secure.
Greg
Says
Mant
they'll be
and
fine.
I would say Greg Mant and Steve Goodman had a Reddit Q&A, and someone asked that question. They said it's at Astrotech, which can withstand Category 4 winds.
Oh, okay,
Steve
good.
is here tomorrow, so.
No, next one.
Week from
Oh, that's right.
Okay, I'll try to speed things up. This is the H-Wharf from this morning. And it was initialized with the beginning stages of this outer eyewall cycle. So that's kind of interesting. You can use your imagination. You can already see kind of the wind field reverting to a larger double eyewall structure with the inner eyewall kind of disappearing. So with eyewall replacement cycles, that just means the inner eyewall typically weakens, but the overall wind field of the storm expands. So it's both good and bad news. The peak winds are weaker, but the broader wind field could increase the storm surge and increase the amount of area subjected to destructive winds. So at any rate, the H-Wharf actually there's Cape Canaveral. It stays offshore. I'll probably go with the global models at this point over H-Wharf, but either way, you can see, as Chris Feldon was mentioning, that over land, you see a substantial weakening of the wind field due to the friction effects.
Why do they have, they've got that, you can see their grid resolution?
Yeah.
And
Yes.
it's much, much coarser than the model resolution. Are they,
This is the public released, I believe, not the highest res.
That's true, yeah.
okay,
Yeah.
but this is the.
Because it should be 2
parent-
kilometer
This is the parent
simulation.
nest?
No. Oh, it could be,
I
actually.
don't
that's-
think
again-
D3 is on here.
Yes. So it's the parent nest just zoomed in, I
Right.
think.
Yeah, but there's something on, I mean, this is their surface, this is their wind field, and it's feeling something much coarser than the model resolution.
But the D3 is interpolated to the parent grid when it's released. So it's just the grid resolution of the output is coarse. But it's definitely, you're seeing the results of the 2 kilometer resolution forecast.
It doesn't make sense that there would be such sharp grid structure in there, whether they interpolate it or not.
Yeah, it is weird though. Could be that, but
I think it's physical. It's good.
just having played with the D3
Yes,
grids,
I know.
or D1 grids myself, I'm pretty sure the D3 grid's in there.
Can you show the precip? You were showing me before the precip. You can see the eye walls better. You got that? Okay.
Okay, so yeah, we'll
Yeah.
look at the precip reflectivity.
This is nice.
Now, one problem with this initialization is it didn't get the structure exactly right. I mean, you see there, it's much more classic eyewall cycle. But actually, as it evolves forward in time, you start to see a clearing of the moat. So that's pretty reasonable. And then right away by this afternoon, it's already showing the inner eye wall starting to weaken, become very asymmetric, with the outer eye wall really taking over. And then it makes landfall near Cape Canaveral. And at this stage, the eye wall cycle is almost completing, but not quite. So that's the situation of land interfering with the outer eye wall in this case didn't really seem to matter.
In the model anyway.
Yeah, but
We don't know if the model really has the physics to deal with that, but
we don't know if it'll proceed this quickly.
What's the lowest pressure? Yes.
This was initialized too low, 925.
921, I think, or something.
Yeah.
Yeah.
So I would take
Standard.
that with
Very
a
close
grain
standard.
of salt.
When these storms undergo eye wall replacement cycles, do you see continued drops in sea level pressure, or is it kind of constant?
You can see it drop, yeah, but
Can't
typically the pressure gradient is weaker
Sure.
as the wind, the pressure field broadens. But as that inner eye wall dies, it'll stop deepening the pressure there. In fact, you can see it bottomed out, and it just really doesn't get any more intense.
And what time is that about? Is that noon tomorrow?
Yeah, so this is noon tomorrow, Eastern time.
It's a little faster than some.
So at this time tomorrow, probably have had landfall or close to it. And as we go further in time, the storm becomes very asymmetric, partly due to land frictional effects, but also the vertical wind shear, which will be impinging from the south-southwest. And at this point, the storm has really been battered by the environment, and goes out to sea with probably just a little swirl in the low-level clouds.
You go back to the landfall.
Sure. Whoops.
Just wanted to point out that we have another Global Hawk mission scheduled for tonight, and it's going to be overflying the storm right about the time it's at near the Cape there. And we have a 12-mile clearance. We can't go within 12 miles of the coastline that drops ons and stuff. So it's going to be real tight. We have a racetrack pattern going up and down the coast with overflying the storm. And we have two remote sensors, microwave sensors on there, which will give some really good information, I think. But if this thing is 12 miles offshore, we'll nail the center and get a really good indication of the structure. If it's 10 miles towards the coast, we'll just have to be settle for the eastern eye wall, perhaps. And that data is transmitted in real time, by the way. And the EC model actually assimilates it. The GFS does not yet assimilate it, but the EC does.
Does
So-
it drops on?
Yes, yeah. The HWARF model does assimilate the tail Doppler radar information from the P3 planes, I believe.
Mhm.
So that's where some of the initialization of the HWARF comes in, real critical initialization from their radar information. But I think that's the only model that does that right now.
Yeah, I don't know how the newest version, but I remember 2015 it rejected a lot of the inner core data and just used environmental.
You know, I think it's gotten better, but
Yeah.
I don't know. You know, they have an
Shane,
experimental version.
What is your surge model setting up in the Cape there? You had.
It was finishing when I came in here, but
Yeah.
if you pull that,
Let's bring that up next. Did you have that
I
on
got a
yours?
slightly
No, I
better
didn't.
explanation. I sent off to get an explanation, a slightly better explanation of that surge map.
So yeah, this surge map is a 10% exceedance based on P/.
Right?
What's
So-
that
so-
initialized on, Sean? What's that initialized
So
on?
what they do is they take the forecast track,
From what time? 12Z? Or
the current forecast track, and they look at a range of possibilities given intensity errors and track errors. So they'll basically create an ensemble
Yeah.
based on their forecast track. So they look at slosh outputs from all of those. And what you're looking at is what's called the 10% exceedance. So there's only a 10% chance it will exceed that value. So another way to put it is there's a 90% chance it'll be less than that value there. Okay, so this is sort of on the end of a worst case scenario type of situation. So the slosh, so I ran a straight slosh run on advisory 33, and my water heights were about 6 feet. across this area, Brevard County. That's the highest it got was 6 feet. So depending on the ground elevation, you know, if you're at sea level or below sea level, of course, you'd be higher than that 6 foot amount. Once I get back to my desk, it'll be finished, and I'll send an email out with what it looks like.
So yesterday, this was not even in the red, that's 9 feet or greater.
Yeah,
It's been increasingly going up as the forecast has been moving toward this location.
So this here is based on the NHC 10 AM advisory?
The advisories, yeah.
Cool.
yeah.
So it should say advisory 34 there.
Where is the launch pad located at?
There's a whole bunch of them if you look at Google
Yeah.
Maps. I have no
Oh,
idea.
yeah.
This
We
is
tried
Air
to-
Force.
There's probably like 20 of them.
This is the Air Force
Number
Base.
41, if that helps.
Ouch.
It's further to the north.
Further to the
Doesn't really matter.
Yeah.
It's all color.
one of the issues we were talking about earlier is that, you know, the building might be able to withstand a Category 4 wind. The issue a lot of times though is whether it's waterproof.
Yeah.
Not necessarily even the storm surge, but some of these buildings they will be made to shed some, you know, like shingles are made to shed. You know, they're made to take the wind energy out. In a similar way, they construct buildings to do that same thing. And so you actually get rainfall penetration at times. They may still have water in the building. I don't know how it was built, but it's not that uncommon for that to happen.
It's really protective covering.
Maybe that's what Mike was telling me, that they put some sort of
Yeah.
Yeah,
balloon.
It's
cover.
protective
A
covering.
tent.
I heard the word
That's our
tent.
fancy, it's a fancy name for it.
So Francis was Category 2 and passed 100 miles south of there, and they had tropical storm winds that had $100 million worth of damage.
Yeah.
Francis, that was tropical storm winds.
What's high tide? Does anyone know?
I don't know.
I didn't know look at that.
So I'm looking at the radar though, I mean, I don't see a whole lot of
Yeah.
landward motion there. It looks like it's already going.
That's,
parallel.
that's likely a wobble.
Yeah,
Yeah, I mean, if you look at
It's 90 minutes.
some of the earlier forecasts, especially the CMWF, or no, maybe it's the GFS, it is now going right of a lot of the tracks.
Oh, so it catches them.
So that,
And so, yeah, it may be
Yeah,
continuing
it's
that pattern to the right, and that would be an interesting thing to follow.
again,
Again, just a 20-mile difference can make a huge world of
Oh,
difference. So,
well, even less than that, because the orientation of this path to the coastline, I mean, if you move it a mile, when it would make landfall on the coastline, I don't know what the exact math is, but it could be 5 miles because of the orientation of that coastline. But these are really hard when they're coming in sort of at this trajectory. Yeah, that angle is really difficult.
Next high tide will be at about midnight tonight, according to Tides for Fishing.
so is it going up does the tide time, is it going this way or is it coming down this way? So-
I just had a point.
Yeah, but is it, I mean, so is the high tide like at Canaveral, then going up the coast and then Jacksonville a little later, or is it coming back?
I did get a message from my friend that lives in Nassau. She just sent me a message. She just woke up from a nap. So I think that tells you that everything is okay now in the Bahamas. She just got up from a nap.
Well, that tells you it was a rough night. Until now she
Yeah, she didn't sleep much last night, but she got up from a nap. So she goes, I don't think that'll be very exciting for your briefing, but
it tells us what's going on there.
well, okay, so I think that's about all I have for the forecast. I'm happy to look at more products or take questions. A lot of good discussion here. But the overall message is that it's still a kind of a complex forecast within the next 24 hours, and it really just depends on the track and the intensity as well because of the eyewall replacement cycle. It does appear that this could have been a lot worse without this eyewall cycle starting when it did. If it had waited to start till later today, we might be seeing a Category 5 prior to landfall. So hopefully that doesn't happen. I mean, there might be a chance that could still occur, but I would say it's the probability of that's decreased quite a bit. So that's about it.
Thanks.
Thank you guys.
Thank you, guys.
Thanks for coming.
Stay at home and watch.